Okay, so I recently found out a really cool way to integrate. I call it like integration by linear algebra, okay? So let's say you want to integrate, I don't know, Jared, give me a linear expression.
2x plus 3.
Okay, so we have 2x plus 3 on the top, and let's say you have like x squared plus, I don't know, 5x plus 6 on the bottom, right? Dx, right? Well, you obviously you can't sort of like factor and cancel since there's a 2 here, but there's not a 2 here. But let's ask what if on the top there was something easier that we know how to integrate. So what if there was one of the factors on the top? So let's factor this. Two numbers that multiply together to get 6, but add together to be 5. That's 3 and 2, right? X plus 3, x plus 2, right? So what if there was, instead, an x plus 2 on the top right here? Right? Right? Then it's super easy. We could just use u sub. Like we could cancel it out, so we'd get what? The integral x plus 2, 1 over x plus 3 on the bottom, right? Because those cancel out. And then this is, of course, equal to what? ln of x plus 3. So ln of the absolute value of x plus 3. We won't worry about the plus c for now, right? That's right. And then what if it was the other factor? So instead of x plus 2, let's do x plus 3 on the top, right? All over our x squared plus our 5x plus our 6 dx, right? Well, this is, by like the same sort of logic, it's ln of x plus 2, right? Okay. Well, look, we sort of have like a linear term on the top and a linear term on the bottom, right? And these two guys, they're linearly independent, right? Like, so, these guys are linearly independent, so, right? So, what if we try and make them like a basis vector for a space and try and express our original integral as a linear combination of these guys? Okay, so, let's see. So we have our integral of 2x plus 3 all over x squared plus 5x plus 6 dx, right? Well, it's going to be some linear combination. So some a times our first integral, x plus 2 all over x squared plus 5x plus 6 dx, right? Plus some scalar b times our second integral, x plus 3, okay, and then our x squared plus 5x plus 6, right? dx. Okay, well, notice the top right here, okay? And then we have this top right here, right? So we can just set them equal. So we have what? 2x plus 3 is equal to a times x plus a times 2, right? Plus b times x plus b times 3, right? We just distributed this a on the inside, right? Okay, notice. Dang it. Notice, I hope this isn't too light. Notice that we have our x terms right here, and then we have constant terms right here, right? We could split it up. So we get, here, I'm going to just move over. Okay, we get 2, let's do the x terms first. We get 2 is equal to what? A plus b, right? Okay. And then for our other terms, you get 3 is equal to what? 2a plus 3b. Okay. Now we have a systems of equation, right? And let's see. Okay, it doesn't look like they're parallel, meaning that these two vectors span, like this vector is inside the span of these two, meaning, you know, it's solvable like this. Okay, let's do it. Jared, do you want to solve it? What should we do first? Or, okay, let's just
get a by itself.
We could subtract it and get b by itself. We can multiply everything by 2, so like this. And then we could subtract the equations. So we get, what's 4 minus 2? 4 minus 3. We get 1 is equal to, a's cancel out, so we are left with, what, 5b?
Negative 1b.
Did I mess up?
Oh, never mind.
No, I did mess up. Instead of 5b, it's negative 1b. Good catch. So, negative 1b, right? Okay, we know b, therefore, is negative 1, right? We did multiply by negative 1 on both sides. So, we get b is equal to negative 1. Okay, now what's a? Well, we know a plus b equals 2. So, a minus 1 equals 2. So, a is equal to 3, right? Cool. Now, we have our a and b. So, let's plug them back in here. So, we get the original integral, right? And I'll just write it down here. Is equal to a, which we know is 3, times this guy right here, which is this guy right here. So, times ln of absolute value of x plus 3, right? Plus our b times this guy. So we know our b is negative 1, so this plus should really be a minus, okay? And this guy is this guy, so we get ln of absolute value of x plus 2, okay? And then we can't forget, if we're asking, like, what function when you differentiate it, you get this. You know, it doesn't matter if it's off by a constant, so plus c. And that is the answer. So, super cool method. Okay, so I don't know, it's up to you guys to check by differentiation if you get that. But okay, that's it.